Hi folks, this is Professor Schwitkus again. We're going to be now talking about comets, the second installment on the little guys. And here's a picture of Hale-Bopp from 1997. I don't remember that, but I should. I wasn't very much into astronomy at that time. I was building satellites and interested in triathlons and sort of getting into taking my scouts and going climbing. So those were sort of what I was interested in at the time. But since life changes, I'm interested in astronomy now. So, oh well. The point being is comets are pretty amazing objects. You should see them. Astronomical events are pretty amazing. You should see them. An example being in 2017, there's going to be a complete solar eclipse running from Seattle down to Nashville. Somewhere along the line, you've got to go and see it. All right, so we'll talk about comets now. Pretty significant thing about comets is it's believed that that's where water came from that got deposited onto the Earth. As it says here, quite a lot of water hits the Earth every day. 100 tons of meteorites hit the Earth every day, and I think it's something on the order of 30 tons of water gets deposited on the Earth every day. Now, that isn't a big deal on any particular day, but as you know, that adds up. Now, this information about that I see here comes from the astronomy picture of the day, and here is the date, 1997, and I think that's May 30th. I've tried to research this a little bit more, and I've gotten nowhere. So if you can find out some more information, please let me know. Okay. So, some famous comets here. Basically, there was the Hale-Bopp. There were some comets that the ancients, if you will, the guys in the Renaissance found, which sort of led people to believe that the current ideas about heaven and hell and the formation of the world about them was incorrect. So as we talked about with Tycho Brahe before, the great comet of 1577 he measured, and with a friend in Berlin, he being in Denmark, and they showed it was beyond the moon. And remember, at the time, they were of this belief that comets must be occurring in the Earth's atmosphere because everything on the Earth is decadent and decays, and here you have a comet. It must be decadent and decaying, right? So it must be in the Earth. So, but here it is beyond the moon and belonging to the cosmos. And remember, at the time, everything in the cosmos is perfect and unchanging. All right. Halley is the most famous one of all of these. I did see one of these guys, and I saw one a couple of years ago. I forget what it was called, but that was pretty amazing. Comets have basic structure. They have two tails. One is a dust tail, one is an ion tail. The ion tail goes directly away from the sun in a straight line. So these are particles, and the solar wind strikes the comet and pushes these things back. The dust tail is basically falls back along the motion of the comet, and that's so this is evolution of stuff coming off of it, off the comet. It's burning off, melting off, turning into gas, things like that. And we'll see more pictures of that later on. You can consider comets as basically a dirty snowball, and I have seen various places where they actually have created them for you. Griffith Observatory was one, and then also at UCLA they have a day where they're doing astronomical type things, and they'll just collect a bunch of stuff and make it for you right then and there. We'll see the effect of this loss of material when comets get near the sun. But if you have a comet that's periodically going through the sun, around the sun, not through the sun, going around the sun, then that comet will get smaller and smaller and smaller as the material comes off of it, until at some point there's nothing left. So here's a picture of Halley's Comet from 7,700 kilometers away, and you can see the gases coming off in a couple of different regions. So if you remember the movie Armageddon, they were correct in that regard. These things pop off at all sorts of different places, and it's sort of not really sensible, if you will, just sort of almost random in appearance where these things where the gases come off with. For that reason, very early on, people had difficulty in projecting where these comets would move, because it seemed as though they didn't follow the strict trajectories that Newton would expect, or Newton's laws would require. And basically the reasoning is that, think of this guy as having jets coming off of particular places, and all of a sudden you have a jet popping off this way, and it's going to cause this nucleus to move in the opposite direction this way. And so that wouldn't be predicted according to Newton's laws. You have another gas jet coming off. We have two different types of comets, long and short periods. They come from two different regions in the solar system. These mostly come from the Kuiper Belt, of which Pluto is one of the objects there in the Kuiper Belt, and then we have the Oort cloud. The short period comets are roughly in the ecliptic plane as well, and the Kuiper Belt is a donut sort of shaped affair in the orbit in the ecliptic plane, so the plane of which all the other planets operate in, if you will. The long period orbits, comets, are in the Oort cloud, and that is in a region that is shaped more like a disk. I mean, not a disk, a spherical object around the sun. So exemplified here. Here is the Oort cloud, sort of a circle, a ball, a sphere around the solar system, and this is our ecliptic plane. And you can see that there is an inner Oort cloud that, I don't know, maybe this is really the Kuiper Belt, as we saw here. The UCLA link here, let me show you what that is. They talk about the Kuiper Belt in a lot of detail here, and so that's something that you could look at and peruse on your own. Okay, so let's go back here. And the fate of comets, as we spoke about before, they evaporate and they will disintegrate, and they could run into a sun or a planet. And so we'll take a look at ISON here. This is one that I was hoping to see and wasn't able to because I was teaching an astronomy lab class, and those go until 10 o'clock at night. And when we observe these comets, we can observe them in the morning or in the evening. As they get closer to the sun, we see them. But that means that we see them at sunrise or sunset. So at sunset, I was going to show my astronomy class this guy. And so at sunrise, I was not paying attention to this thing. Sunrise when it was approaching the sun, and sunset would be when it was leaving the sun, if you will. This comet disintegrated essentially before I got to see it. The disintegration occurred as it approached the sun. So this is one of the satellites that are looking back towards the sun. It gives us information about the sun. We'll talk about that. We'll talk about that with the sun. Let's see. I forget what the I forget what the object. What the satellite is called. Okay. Oh well. At any rate, let's play the video for you. Here's the comet here. It's running into the sun. It's getting brighter and brighter and brighter. We're going to another sensor on the spacecraft. And then where did it go? You see it over there, but it's a lot dimmer than it was before. And here it's basically all gone. I'll play it once more and you can see, look at all this stuff coming off of the sun. Just unbelievable, the material that is coming off of it. And that's the solar wind and the solar storms and the things that we're concerned that would hit the Earth. As you can see here, it's amazing anything can get so close to the sun and still survive. Obviously, it doesn't survive. Now, this is this particular ring here is an artificial eclipse maker, and the sun is actually this. The sun's photosphere is actually extends out to that line there. Okay, so let's continue on. We're talking about now these comets running into planets, if you will. Let's see, basically, when these things run into planets or Earth or objects, they've got to lose energy. They don't get captured. They have to interact with another object. So Jupiter is the one that most occurs happens with, and comet Shoemaker-Levy 9 is the one that is most frequently talked about. It was predicted to strike the planet Jupiter. It disintegrated beforehand because it got too close to Jupiter, and we spoke about that before in terms of the Roche limit, and so we had various pieces of the comet striking the planet. So these are some reasons why Shoemaker-Levy 9 was so interesting. Essentially it's the first time we saw any comet hit an object before, and we could determine what the object was made out of by its interactions. So there were quite a few interesting things about it. So here's a picture of it. The impact was strong enough to be about the same size as the dark spot. Here we go with various, these various objects hitting it, and then here's the great red spot. And infrared, lots of energy hitting the surface. And we'll now leave us off here and pick it up again. We'll talk about meteorites and the nemesis theory.